Good. So I'm going to cover a question. Welcome everyone. So we're going to cover a question on point of inflection and curve sketching today. Point of inflection, points of inflection, and also curve sketching today. Curve sketching. Okay. So point of inflection. Let's take a question that will lead to a point of inflection. Okay. So this is the same method that we treated in the last video, maximum and minimum, where y is equals to x cubed minus 3x squared plus 3x. Okay, and we're going to hence sketch the curve, sketch the curve, sketch the curve. Okay, so you say we should get our stationary point and we should also what sketch the curve. Good. So let's get our stationary point, because without stationary point you can't sketch the curve. What's the first step in solving it? So steps for turning point. Step one, find the y dx. If you have forgotten, find the y dx. So the y dx of this becomes what? 3x squared minus 6x plus 3. Okay. The next step is what? Set the y dx equals to what? 0. So 3x squared minus 6x plus 3 equals 0. Use your quadratic, use your calculator to solve this, you can get your answer. But let me just divide all through by 3. X squared minus 2x plus 1 is equal to 0. Then this becomes x minus 1 all square, because 0, and we have x is equals to 1 twice. Okay? Okay, can I use your calculator to get the answer? Or you can use your formula method. Anyone. So just make sure you're fast. Good. So we have 1. So we only have only one answer in this place. We don't have 2. Good. So from there, the third says that what? Now substitute the what? The value of x inside the original equation to get the stationary point. So y is equals to x cubed minus 3x squared plus 3x. So now let's substitute the value of x inside it at 1, abi? So 1 cube minus 3 open bracket 1 square plus 3, okay, 1. That gives us what? 1 minus 3 plus 3. That gives us what? 1. So we say what? Y is equals to 1. So our stationary point for this is 1 comma 1. So how do you know if this is a maximum, minimal, the rest? That leads us to finding the square y over the s square. But I have an arc. But before that, let's just look at this first. So the square y over the s square, you difference your dy dx once again, right? Difference this guy once again. So you have 6x minus 6. So substitute x equal to 1. The value of x inside this, you have what? 6 over bracket 1 minus 6. What do you have? 0. And what did I say earlier on? So I said that anytime that you have is equals to 0 at s equals to xi, it's a point of what? Inflection. It's a point of inflection. So we say that what? We'll now finally say that 1 comma 1, it's a point of what? Inflection. Inflection. Okay? Because the square y over the s square at x equals to 1 is equals to what? 0. So it's point of inflection. Good. So we've done that. Now, curve sketching. What is curve sketching? Now, when we talk about curve sketching, it's easier, okay, because in your exams, you just see the curve. They just tell you what's the curve of this. Although for curve sketching, you have to get your stationary point first. So after getting your stationary point, okay, after getting your stationary point, you know how to curve. So you know where to put, how to draw your curve. So because you're sketching, you're not plotting graph. So understand the difference. You're sketching, you're not plotting graph. So you're just doing a sketch, a rough sketch. use a y axis, use a x axis. Okay, y minus y minus x and x. So if I'm giving, let's use the former question that we did on the maximum and minimum. Okay, so in this point here, we got minus 1 and 7, right? Minus 1 and 7, and we got 3 and minus 25 as our maximum and what? Minimum. Maximum and minimum. And what they call, another name for stationary points are called what? That's called what? Turning points. Turning points. Turning point. So anytime you have maximum and minimum, they're always taking this kind of shape, like as if something like this. Their sketch is always giving this kind of movement. Can you see that? So anywhere they are, so you can have something like looking like this also. So anyhow, hmm? Minimum, maximum. So but yeah, we know that x1, x2, x1, y1, x2, y2. So when x is minus 1, y is at plus 7. So this is positive y, right? So plus 7, let's say plus 7 is here. Here is minus 1. So around here, that is where we have the turning point. So just like this. Just bend, do a curve around that turning point. Okay? Simple. You come here, 3 and minus 25. Minus 25 is negative y, abi? Because that's y, where y is negative. So minus 25, let's say here. And here is 3, positive 3. Positive, this is a positive x-axis. So this is the point I'm talking about. So also draw a curve, a turning point also. Good. So join both points together. Good. That's it. That's the curve for this. You have sketched this curve. Okay? You've sketched this curve. Now, for point of inflection, most time, I think point of inflection cannot have maximum and minimum. Okay, question that give point of inflection will not have maximum and minimum. So let's look at the one that have 1 and 1. But I'll give you a simple arc so that when you see a curve, you just get it. When your if the cubic function you are given, a arc for cubic function, if a cubic function you are given, and it is a positive s cube, that means the y you are given starts with a positive s cube, or inside the you saw positive s cube, a cubic function. Okay, it will always take this kind of concavity change. Okay, so let's take that concavity change. But if what you have is a negative s cube, so let's take this kind of concavity change. Good. Let's take that concavity change. So I think this will help you when you're plotting. So for point of inflections is like this. It's not like maximum and minimum. It's always like this. So there's a stretch around that point of inflection. So this point here is always around this where the concavity changes. Is always around where y and x are located. So in your point now, we know that question we solved earlier. We got 1 and 1. So here will be this point here will be 1, positive 1 on the y-axis, and also be telling us that what it is positive x on the what? On the x-axis. Positive 1 on the x-axis. So it's been in this region, this positive region. Okay? So that's the hint for that. It will not go below that. Okay? So we've come into the end of curve sketching. So I'll give you a point that you can plot. So plot the following sketches, or sketch the following curves. Okay, so if I change sketch, let's say I give you something like 3 minus 2, and we have 2 and let me see, 2 and minus 10. Let me see, mm, minus 2 plus 10, minus 2 plus 10. Okay, so we can just call this. Mm, yeah, and you can just tell me the answer for this course sketch and try to solve questions on that. Okay, I might later drop a question bank on curve sketching later. Okay, and your second question I need to comment is y is equals to s cubed minus 7s squared plus 1, y is equals to 3s cubed plus 4s squared minus 6x. So solve each of these questions and also get their stationary points, either their maximum, minimum, or inflection points, and also plot their or sketch the curve. Okay, just sketch it. Good. Thank you for staying tuned to our videos. Kindly comment videos that you want us to make for you and more for you guys. Thank you very much. Stay tuned.